I'm pretty sure that the first time you went to the beach, you were mesmerized, especially by the waves. And I can bet at least once in your life you have thought, where do these waves come from? But you would have never thought that understanding the same waves could help you understand the universe. Here's a little history. Euler was the first person to investigate about waves. Yep, this guy. He was intrigued by waves just like you, but he wasn't at the beach. He was on the ship, and he was really intrigued by how the ship moved up and down because of the waves. And so the man he went straight to work. He wanted to figure out how can he model these waves so that he can understand how the ship goes up and down. And he used Newton's laws to figure out how things move in waves. The first step to understanding waves is to understand how many things are actually waves. And you would only notice that once you actually take a closer look at what waves are. This is a wave, and the one thing that makes it unique is that it doesn't move forward, but it oscillates. It moves up and down. Therefore, anything around you that oscillates is a wave, like your clock, or a spring, or a trampoline. Anything that oscillates, that moves front and back, is a wave. The interesting part is to figure out how a circle is related to a wave. And you can see here how a circle is actually connected to a wave. And further in the video, we'll realize that the math behind them is literally the same. Now, if you do remember high school math, you probably know what a wave is. It's just a sine curve. This is a sine curve, but it's also a wave. But you might say that not all waves are the same. Some are like this, while some are like this. But in real life, most waves are like this. And our job is to somehow come up with some mathematical formula that'll help us understand what these waves actually are. Okay, let's start with this general formula. This is the general formula for a wave, where the sine means that it's a wave, where k is just a measure of wavelength. The smaller the wavelength, the larger k is, and the larger the wavelength, the smaller k is. And omega is actually a measure of frequency. The bigger the frequency, the bigger the omega. The smaller the frequency, the smaller the omega. The x is actually the distance, and t is the time. And now here, the a outside the bracket is actually how high the wave is. And so if you know all of these properties, you can figure out what a wave looks like. Now, most waves are not the same, and you can manipulate anything that's inside the bracket to the scenario that you're in. For example, this spring with a block. The spring in ball is actually a wave because it oscillates. It moves back and forth. And so you can use the same formula to really describe the motion here. For this situation, you just have to remove the k and the x from the formula, and you get your simple harmonic motion. This tiny formula actually describes a lot of motion that are around you. Simple harmonic motion is one of the most important type of motion to understand the universe around us. Not all waves are quite simple. Some of them are like this, and you might be wondering, how the heck can you describe something in math that looks like this? Well, if you look closer, you'll see that nothing about the wave changes except the amplitude or the height of the wave. The height of the wave decreases, but it exponentially decreases. We just have to multiply the a value by something that is going to make it decrease. So, what is that? And that's this constant right here, e. E raised to anything of a negative number is going to decrease the a value like this. And so you just multiply a by e raised to minus whatever. And it could be -5, -500, it depends on your scenario. And so now you've got your final formula that actually describes a wave. And this formula is actually used in so many different parts of the universe that you're going to be amazed. This understanding of waves can be applied to electrical circuits. Like how does waves from the sea somehow resembles how the electrons move in a circuit? But it actually does. The movement of electrons inside a wire can be modeled by the equations that we discussed. It also governs the unseen world of electromagnetism, and that's just crazy. Everything around us is based on electromagnetic waves. The Wi-Fi, your phones, your laptops, everything uses electromagnetic waves. And these equations are crucial to understanding them. And everything is made up of atoms. And to describe atoms and an electron's position in an atom, you need to be able to understand simple harmonic motion. Because without waves, you cannot actually describe the universe that we live in.